Okay, let us proceed to the second questions. A closed pipe produces a fundamental note at 412 Hz. It is now cut into two pieces of equal length. Calculate the frequency of the fundamental note produced by each piece. Okay, first of all, it is started with a closed pipe. Okay, it's a closed pipe, produce a fundamental mode. Okay, this is a fundamental mode frequency, and then cut into two pieces of equal length. Yeah, cut. Calculate the frequency of the fundamental node. Okay. Okay, let us start with drawing the diagram. I always draw the diagram. So for the closed pipe, okay, the fundamental mode is like this. This is the closed pipe. Fundamental mode is like this. A node with antinode. Okay, the closed end is a node. The open end is always an antinode. So from here you can see this length is equal to 1/4 lambda, because the distance between node and antinode is always 1/4 lambda. Okay, we can write that down first. The length of the pipe is 1/4 lambda. So this lambda is equal to 4L. Okay, lambda equal to 4L. Now let's find out this frequency. He said the fundamental frequency for the closed pipe is 412. Okay, so just use the formula V equal to F lambda. So the frequency is equal to V over lambda. Okay, the fundamental frequency is 412. And the lambda given is lambda I got from here is 4L. So just substitute with 4L. So from here I got a ratio of V over L. I got a ratio of V over L. So multiply to the 4 multiplied above, I got 1648. I got this value. This might be useful. Okay, so let us continue. This one we just keep it first. Now he says the closed pipe is being cut into two pieces of equal length. So I cut this closed pipe into two pieces. So what do you expect? This length cut into two pieces. That means each of them is half length, isn't it? Half length. And I also will end up with only one closed pipe. Another one is surely an open pipe. Because it's like you cut in the middle. You see? You cut in the middle like this. So this part, the left-hand side, become a closed pipe. The right-hand side is an open pipe. Because it has two open ends. Okay? And he says that what is the frequency of the fundamental mode of each piece? That means for each piece, also we want to find out the fundamental mode. Fundamental mode for each piece. So for each piece, this is how the fundamental mode looks like. Okay? Because he said want the fundamental mode of each piece. That means I want the fundamental mode of the new closed pipe and also fundamental mode of the new open pipe. Okay, so the closed pipe fundamental mode is always node with antinode, and for the open pipe is always antinode with antinode, because for the open end it always antinode. Okay, because the air there can vibrate freely. So both of these are fundamental mode. Okay, so what's the frequency of them? What's the frequency of this fundamental mode? Very easy. So the new length is half length. This half length is equal to 1/4 lambda. Okay, let's continue. This half length is equal to 1/4 of the lambda. 1/4 of the lambda. So let's find out the lambda. This simplify, we get 2. So this is lambda is equal to 2L. Lambda equal to 2L. Now we just use the formula V equal to V equal to F lambda. So let's find out the frequency for this. V over lambda. Okay, V, and then this lambda is 2L. Just substitute with 2L. 2L. So here I got the ratio V over L here. Do you see that? So the V, I can utilize this one, V over L. V over L, I substitute here. I substitute there. Half times V over L. V over L is 1648. 1648. So what's the answer? I got it for 824 Hertz. That's the fundamental frequency. The fundamental frequency for the closed pipe. Okay, for the new closed pipe. Okay, for the new closed pipe. Now, for the second one, the open pipe. So do the same thing. Okay. So this one, half L is equal to how long? Between NT node with NT node is half lambda. Okay. Between NT node with NT node is half lambda. And between node and NT node is 1/4 lambda. Between NT node with NT node is half lambda. Okay, half lambda. So yes, we can cut off, and then we can get the lambda, which is equal to L, and then V equal to F lambda. We can get the frequency for this, V over lambda, and then V over L. Yeah, V over L. I got it just now. V over L is 1648, isn't it? 1648. So the answer of the frequency for this open pipe is 1648, isn't it? Yeah, 1648 Hertz. Yeah, this is the new open pipe. The frequency for the new open pipe. Is that correct? Yeah, fundamental frequency for each piece is 1648 and 824. Yeah, 1648 for the open pipe, 824 for the closed pipe. Okay, so very simple, yeah. Just remember to draw the diagram. From there, you get the length of the pipe in terms of lambda, and then you apply V equal to F lambda. Yeah, V equal to F lambda to find the frequency, and you can find for all. Okay, just remember to know the shape of the fundamental mode. Then you are good to go. Yeah. Okay, so that's all, and see you in the third questions.